Hello and welcome to the Edupedia world. Well, in this tutorial, we'll start learning what are inner classes. So let's begin with this tutorial. So you see, inner classes. You have been asked to develop a new linked list class. Remember that the linked list store information in nodes which the user never uses directly. Some design question arises. Question 1. Should the user be able to use the node class at all? Well, the answer is probably not. At least it can confuse the issue when they are trying to figure out how to use the list class. Then we have another question. How can we hide the node class away from end user? Well, the answer to that question is inner class. So let's see. Inner classes are standard classes declared within a scope of a standard top-level class. They are a part of class that contains them, and they can be public, private, etc. just like other data members. And then we'll see some of the examples of inner classes. One of the examples that we have already seen while studying collections was map.entry class, which is present under the map class. Okay, so it's an inner class within a map class. Okay, so even if you haven't seen them, I'll show you that. So when we talk about inner classes, we can categorize them in four types. So one is static member classes. That means your inner class will be declared as static. Then we have member inner classes. That it will be a simple member of your class like any other data member. Then we have local inner classes, and finally we have anonymous. So we'll cover each of them in detail. So let's begin with static inner class. Well, when we talk about a static inner class, so static inner class is declared static within the top level class. Sort of like a class level member variable. Okay, so you can see like a top level class cannot be static, but a inner class can be static. Okay, so any inner class like within a top level class will be treated as a normal data member, and that will be treated as a static. Well, they follow same rules as standard classes. That is, private static classes cannot be seen outside the enclosing class, and public static allows the class to be seen outside. Okay, so except that they are static classes, they follow the simple rules. Now, static inner class. Why use a static member class? So, firstly, why there is need of a static inner class? Well, if you have a type that is essentially a part of object's makeup, you can define that type as a part of object's type. Okay, let's say for example, I'm having a class linked list. Now my linked list contains a class as node. Now node can have a data member and a link. Fine. So node instead of defining node as a class outside linked list, since this node class will not have any scope outside the linked list, because I want to make it preferably for linked list. Without linked list, node does not have any scope. So I should make it as a inner class. And why to declare it as static? So that it can be accessed without creating the object of your outer class. Okay. So that is the use of static member classes. Then just think about a map class. So there is entry. Entry like key and value pair is called entry, and it's critical to map. So to make it an inner class, the user of map will want to be able to refer the entry object. So it needs to be public. So you see the inner class that we talk about is entry, but when we call it map.entry, that's because we can actually access your inner class with the outer class. So outer class is map, and we don't need to create an object of map to, access the inner class. We can directly access it with the name of your outer class. Like outer class is map dot inner class, which is entry. Why so? Because it's a static inner class. That's why. Okay. Now think about our new list from earlier. Node could be the inner class. The user won't be using node object. So the type can be private over here, because we don't want to, user don't want to directly access this node class. It's for the internal reference of linked list. So that's why we can keep the node class as private. So it depends upon how we want to use it. We can keep it private, public, and similarly we can keep it static also. Now this is an example of a static inner class. You can see we are having public class demo list which implements list. Okay, now this demo list is implementing list class. Inside this class, we are having a private static class which is node. So this is an inner class. Why it is an inner class? Because it's a class inside another class. So there's a class demo list. Now this class demo list is having another class which is node. So it's a class within a class. That's why it's an inner class. And it's a static inner class because it is having the static keyword. So now you see this inner class is having a constructor which is a public constructor node. So it's perfectly fine to have that, and it's taking value and it's setting this dot value equals to value, and then next equals to previous equals to null. Okay. Outside the constructor, this inner class is also having like next, previous in value. So this, like you can see, this inner class is also having objects of its own. So it's having next, it's having previous, then it's also having a value object. So then like in the list class, we have created objects of node class as is node head and node tail. So these are to keep the track of start and end of the list. So this is how we can implement your list by using node as an inner class. So what that was about static inner class. Let's study member inner class. Well, member class is nested top level class that is not declared static. A member class has additionally this reference which refers to enclosing class object. This reference is available via enclosing class dot this. Okay, so if you have to access any member in a class, so you do it like enclosing class and dot this. Okay. Now member object are used to create data structure that need to know about the object they are contained in. And member classes cannot be declared as static variable. So they cannot have like static variable or methods or have nested top level classes. Okay. So a simple member class demo contains member class named member, and then objects of member class type have full access to data members of outer class they are associated with. So let's see this simple member class demo.java. Okay. So, and now think about the iterators that we can get for collection or list. They need to know about objects they are referring to. They need to have full access to collection data so that it can be retrieved or removed. The user of our class should only be able to create these objects via methods that the class provide. Okay. So now the demolist.java is there, which is like demolist iterator type, and iterator is a method in it. Now to support a member class, we have two extra kinds of expressions that are provided. So one is like x is equal to this dot data member. This is valid only if data member is an instance declared by member class and not if data member belongs to the enclosing class. Fine. Another case is x is equal to enclosing class dot this dot data member. This allows the access to data member that belongs to the enclosing class. So I hope so you got it. If not, we cover an example also. Inner class can be nested to any depth, and this mechanism can be used with nesting. Now, member class object can only be created if they have access to enclosing class object. So now you can see member inner classes. Member class object can only be created if they have access to an enclosing class object. This happens by default if the member class object is created by an instance method belonging to its enclosing class. Otherwise, it is possible to specify an enclosing class object using a new operator as follows. So you can see we are having an enclosing class dot member class B, an enclosing class object dot new enclosing class dot member class. So in this way, we can actually access any member class of enclosing class also. Then finally, we have local inner classes. Well, the local class is a class declared within a scope of a compound statement like a local variable. A local class is a member class but cannot include static variable members or classes, and additionally they cannot be declared public, protected, private or static. Fine. A local class has the ability to access final variables and parameters inside the enclosing scope as well as fields from the enclosing class. Okay. So this is about local inner class. Now this is an example of a local inner class. You can see we are having inside a normal class. Let's consider we are having a normal class outside this. So inside this there is a data member like string name which says local class example. Then we are having a method public void a method which is taking some of the arguments and doing some of the computation. And then on this line you can see we are having a local class. So why it is local class? This is local inner class because it is defined local to this method. So if any class that is defined within a local parameter to a block, to a method, to a statement is called as a local inner class. Now this local inner class is having its own method which is again a method. So you can see outside method is also a method and the method which local class is having is also a method. Inside this a method we are printing something. Okay, so this is the whole body of your a method. It's closing over here and over here the local class gets closed. After that inside this outside the a method, the outer a method with the parameters. In this method we are actually declaring the local class object. Okay, equals to a new local class. And then we are calling a method of this local class. So this will actually execute a method, this one. Fine. After that, we are also having final int I equals to 10. Fine. So you see inside a method, we are having variables like j, then final int k, then also final int I. And inside this local class, we are having a local method, which is like printing h. Okay. And if it tries to print w, w will not get printed. Why so? Because w is not final. W you can see it's not final. J again J is not final, so it will give you error. If you try to print K, it will print that because it is final, so you can access it inside this method. So again if I try to print I is not declared yet, it is declared below this, so that's why again it will give an error. And if I want to print like name, so name is fine because it's like a normal member access, so name is defined over here, so you can like simply print that. Fine. After that, inside the main method, we are actually creating the object of this class, which is enclosing class equals to new class, and then we are calling CA method by passing 10 and 50. So this method will get called. Okay, so this is how local inner classes works. Fine. And now finally we are to our anonymous inner class. Well, an anonymous class is defined as a part of new expression and must be a subclass or implement an interface. A class body can define methods but cannot define a constructor. So you see the class body can define the method but it cannot define a constructor. And it is defined as a part of expression. Okay, so as a part of new expression. And there must be obviously a subclass or implement an interface. Okay. The restriction is imposed on local class also apply over here. So just see our example of anonymous inner classes. So this is our class main program. We are having JFrame win. And then we are having public main program. This is a method. Okay. So you see inside this method we are actually having parameter which is then we are declaring this win is equal to new JFrame title. Okay, and after that you see we are doing win dot add windows listener, and within this method has a bracket which is starting win dot add within listener. Within this method we are declaring a anonymous inner class. So you see new window adapter over here is an anonymous inner class which we have declared inside this method. Okay, it is always declared by a new expression. And now this class is having a method which is public void window closing, and it has defined this method over here. Okay, so you see in a nutshell what we are doing is we are actually adding a window listener, and instead of creating a class which is like a window adapter class outside this class, and then creating a object over here, that will not, although it will solve our purpose, but that will be too much of excessive code that we do not need it, because declaring this window adapter as a normal class outside this main program class, and then using a object over here, and then calling this window closing method through a object, what it will do, it will simply increase so many number of lines of code, but we actually don't need this window adapter class outside this main program class. It does not have any purpose. No other class is actually using this class. This class is only used by a single method, which is add window listener. So what's the purpose of creating it as a normal class? Rather, it should be created as an anonymous inner class within this method, that it can be just utilized for this method, and the method can be declared over here. Fine, and whatever we have to do, we can do it. So fine, that's the purpose of anonymous inner class. And since this window adapter that we are using can actually, finally, like this are implementation of some other class, there could be other class and could be implementation of that. So you see, in a main, we are actually creating simply an object of our main program by passing simple example. And all these things are actually happening in a constructor. Fine. So this is how it is executed. Okay guys, so this was our intro tutorial for inner classes. I hope so you have got at least a brief intro of all the 4 types of inner classes. We are yet to do our live examples. So we'll be doing that in our upcoming tutorials. Okay guys, thank you very much. Now let's meet in the next tutorial. Thank you.